Okay, so basically, this isn't going to be that hard. We're going over 3 distinct things. We are going over inequalities in one triangle, the triangle inequality, and the inequalities in 2 triangles. Now, I know it sounds really, really difficult, but I think we can get through it if you just pay attention. William and I thought this was the most important one because it is quintessential in understanding the inequalities of a triangle.
Alright, so the first theorem would be the exterior angle inequality. The measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. So pretty much what that means is, if we draw a triangle right here. Alright, so pretty much what this means is, if we have this triangle right here, and we have an exterior angle right here. Alright.
I see.
These two angles right here will add up to be equal to this angle. Alright?
Okay.
So, this angle will obviously be lesser than this angle, and this angle would be less than this angle. Right?
Okay.
You understand?
I understand, master.
Alright, let's move on to the next theorem.
Sounds good.
The angle-side relationships in triangles. If one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side.
But what does it mean, teacher?
It means, essentially, what you want to do is you have this triangle right here, right?
Yes.
And then this side corresponds to this angle. So, like that, alright? So this side corresponds with this angle.
Ah, I see.
And then this side corresponds with this angle.
Oh, I understand.
Alright. So, the angle, let's just put in some random numbers here.
So it's 10 on that side.
And then
5 on that side. So that means that the right side angle is going to be lesser than the left side angle because the sides are different.
yes, so the side with the greater length will, and its corresponding angle will be greater than the side with the lesser length. The side with the lesser length and with the smaller angle.
I see, but does it work the other way with angles to sides?
I'm glad you asked. We actually have another theorem.
Whoa!
Which is exactly the same, but exactly the opposite.
Most extraordinary.
Alright, so pretty much what this means is the side with the angle with the shorter, the lesser angle has a shorter side than the greater angle. So let's say that this angle is greater than this angle.
Okay.
So this side will be greater than this side.
Ah, I see. So that means if this angle was, let's say, 30 degrees, and this angle was 60 degrees, that means this side would be bigger than this side over here.
Correct. Exactly.
Oh, zoinks, Teach. Thanks for teaching me that one.
All right. So now we have an example problem. Maybe you want to do it.
Sure. Let's see what I can do.
I think you understand it well enough.
Yes, sir. What's the problem?
All right. So pretty much what we're going to try to find is angle 1, angle 5, angle 6. And those are the ones that we're going to try to find which all of them, which one is the biggest.
Huh. Okay. Well, here's what I do know. By the exterior angle inequality theorem, we know angle 1 is going to equal the sum of angles 5 and 6, correct?
Correct.
Alright, by my calculations then, we should assume that because 5 and 6 equal 1, that 1 has to be greater than each of them.
Correct.
Yes.
Excellent, my student.
Thank you, Sensei. William,
Yep.
can I teach the next lesson?
No,
What? Why not?
because I am the designated teacher here.
This is a rebellion. Let me teach or else I'll beat you up.
No, I will never let you teach.
we have respectfully agreed that I will be teaching the next lesson. Isn't that right, William?
I guess.
William and I chose this one because we thought it nicely bridged the gap between inequalities in one triangle and inequalities in two triangles. Inequality. Alright?
My head still hurts though.
Yeah, suck it up. Alright, so there's only one theorem. Easy. The triangle inequality theorem. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Kind of self-explanatory, but you know what? Let's give an example, alright?
Okay.
Alright, so we have a triangle here. Alright, let's take this, let's get that, and we'll connect it right over here. Alright, we'll say this is point Q. We'll say this is point P. And we'll say this is point R. Now, since we know the sum of the lengths of any two sides must be greater than the third side, so this means that PQ plus QR must be greater than PR. And it works the other way too. So we know that QR plus PR must be greater than PQ.
Wait, let me guess.
What?
PQ.
PQ. Got it. Alright, let's see if you can do the third one though. Because there's one more.
Alright, I think this is how it goes.
Alright, let's hear it.
PR
PR
plus PQ
plus PQ.
is greater than
Yeah.
QR.
Well done, my now student.
Not your student.
Be quiet.
Okay.
Okay. We're done with that. Easy. Do you want to do an example?
Okay. Pretty much an example would be, let's get a triangle up here. Alright, so let's just say that this triangle is 7, 5, and 4. Alright?
Alright.
And this is a possible triangle because if you add up 7 and 5,
Uh-huh.
it is greater than 4. If
I
you
would agree.
add up 7 and 4, it would be greater than 5.
I would also agree.
And if you add up 5 and 4, it would be greater than 7.
Wow, that's really simple. I think even my pet duck could do that. Isn't that right, Mr. Quackers?
Quack, quack, yes, quack.
Wow, he can talk too. What a realistic world we live in.
Alright, so pretty much that is half of it.
Okay.
The second half is that this number
Mm-hmm.
has to be greater than this number subtracted from this number.
Okay.
So this minus this would be 3, so this is greater than 3.
I agree.
This is greater than 1,
Mr. Quackers agrees.
and this is greater than 2.
Of course.
And that's it. That's how you find out if a triangle is even possible to be created.
Possible?
If it's even possible.
To be possible. If it's
Yes.
even possible to be possible. Wow.
Inequalities in 2 triangles in 30 seconds. Go, quick!
William and I thought this one was the hardest one because it takes your knowledge from the first 2 lessons and it applies it to the third one, and you can confuse the two between normal hinge theorem and the converse. If two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. However, the converse is basically the thing but in reverse. So if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first triangle is greater than the third side of the second triangle, then the third included angle of the first triangle is larger than the included angle of the second triangle. We all understand that. It's easy. Hinge theorem. So basically, there's a reason that these two triangles are not congruent. See, look, these two sides are the same. However, by the hinge theorem, because this one is bigger, that means this angle has to be bigger. Isn't that right, William?
Yes.
Are we done here?
Yes.
Yes, we are.
Completely.
You just learned 3 new lessons. You are enlightened. You are welcome.
Merry Christmas.